In this video, we're going to look at how to calculate area of a surface of revolution. And in my first example, I have y is equal to 1/3 x cubed on the interval from 0 to 3 about the x-axis. And when we're revolving around the x-axis, we're going to use the formula s is equal to the integral of 2 pi y ds. And ds can equal the square root of 1 plus dy dx squared dx, or it can equal the square root of 1 plus dx dy squared dy. So in this case, we're going to use the first example. So we have 1 plus dy dx squared dx. Because we're in y is equal to, so there's going to be x variables in our integral, so we need the dx. I'm going to start the same way we did with arc length. I'm going to figure out 1 plus dy dx squared and then plug everything in. So dy dx is equal to x squared, dy dx squared is equal to x to the fourth, and then 1 plus dy dx squared is equal to 1 plus x to the fourth. And now I want to write everything into our formula. So we have s is equal to the integral from 0 to 3 of 2 pi times y, and in this case y is equal to 1/3 x cubed. So I have 1/3 x cubed times the square root of 1 plus x to the fourth dx. And now I want to simplify this. So the first thing I'm going to do is take all my constants and move them out front. So I have 2 pi times 1/3. So I'm going to say that I have 2 pi over 3 times the integral from 0 to 3 of x cubed times the square root of 1 plus x to the fourth dx. And now to integrate this, we're going to need to use u substitution. So u is equal to 1 plus x to the fourth, and du is equal to 4x cubed dx. And now I'm going to write this as 1/4 du is equal to x cubed dx. And now I want to write my integral in terms of u. So I have 2 pi over 3 in the integral. Now when we plug 0 in for x, we get 1. And when we plug 3 in for x, 3 to the fourth is 81, plus 1 is 82. And then x cubed dx is equal to 1/4 du, so I'm going to put my 1/4 out front with the rest of my constants. And I have 1 plus x to the fourth is my u, so I have u to the 1/2 du. And now we want to integrate. So the constants simplify down to pi over 6 times the integral of u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3, evaluated from 1 to 82. And now I'm going to combine my constants and leave them out front again. So I have pi over 9 times u to the 3/2 evaluated from 1 to 82. And when I plug this in, I'm going to have pi over 9, 82 to the 3/2 minus 1 to the 3/2, which is just 1. So my answer is going to be pi over 9 times 82 to the 3/2 minus 1. In my next example, I have y is equal to the cube root of x plus 2 from 1 to 8 about the y-axis. So in this problem, we're going about the y-axis, so we're going to have s is equal to the integral of 2 pi x ds. And again, I'm going to calculate the ds inside the square root of the ds part first. So the first part I want to find is dy dx, and that is equal to 1/3 x to the negative 2/3. And now I want to square it, so dy dx squared is equal to 1 over 9x to the 4/3, and then we want to add 1 to it. So 1 plus dy dx squared is equal to 1 plus 1 over 9x to the 4/3. And now I want to plug everything into our formula. So we have s is equal to the integral from 1 to 8 of 2 pi times x times the square root of 1 plus 1 over 9x to the 4/3 dx. And now I'm going to find a common denominator inside the square root. So I have s is equal to 2 pi times the integral of 1 to 8 of x and the square root. Now 1 can be written as 9x to the 4/3 over 9x to the 4/3. So I have 9x to the 4/3 plus 1 divided by 9x to the 4/3. And 9x to the 4/3 is a perfect square, so I can pull that out. So I have 2 pi times the integral from 1 to 8 of x over 3x to the 2/3 times the square root of 9x to the 4/3 plus 1. And now I can move the 3 that's in the denominator here out with my constants. So I have 2 pi over 3 and the integral from 1 to 8, and we have x over x to the 2/3, which is x to the 1/3, times the square root of 9x to the 4/3 plus 1 dx. And now I'm going to use u substitution. So u is equal to 9x to the 4/3 plus 1 du is equal to 12x to the 1/3 dx. And I'm going to divide both sides by 12, so I get 1 over 12 du is equal to x to the 1/3 dx. And now I want to rewrite my problem in terms of u. So I have 2 pi over 3, and I'm going to have this 1/12. So I'm going to have pi over 18 times the integral, and when I plug 1 in, I get 1 to the 4/3 is 1 times 9 is 9 plus 1 is 10. And when I plug in 8, I get 145. And then we have x to the 1/3 dx is our 1/12 du, and we've already factored the 1/12 in, and we have du. And then we have u to the 1/2. And now we integrate. So we have pi over 18 times 2/3 u to the 3/2 evaluated from 10 to 145 And when I combine my constants again, I get pi over 27 times 145 to the 3 halves minus 10 to the 3 halves. And that's how we find area of a surface of revolution.